To find all the zeros of g of x, we need to find first the list of possible rational zeros. So we'll take the constant term, 6. So we want the factors of 6. And we need to get the factors of the leading coefficient, which is 2. So we want factors of 2. Okay, so for 6, the factors are 1, 2, 3, and 6, while the factors of 2 are 1 and 2. So if we make our list, from this, we'll say that our list will include 1 over 1, 1, 2 over 1, 3 over 1, 6 over 1. So that's going to be 1, 2, 3, and 6. And also 1 half. We'll also include 1 half. 3 halves. Okay, 3 halves, I can still insert it here. 3 halves. And 6 over 2 is 3. So we already have 3 in the list. So this is the complete list of the possible rational zeros. Again, these are the possible rational zeros because these numbers are rational numbers. So we call them rational zeros. So now we are going to take the coefficients of the terms. So we start with 2. First, let's check the exponents. 5, 4, 3, 2, 1, 0. So that means we don't need to put a 0 somewhere. So we'll just start with 2, then 9, 5, negative 15 is next, negative 7, and positive 6. So again, this number is from here, 9 is here, 5 is from here, negative 15 from this term, negative 7 from this term, and 6 from this term. So, okay, so let's test our first 0. So we're going to start off with 1. See if 1 works. So we bring down, first step is bring down 2. Multiply 2 by 1, we get 2. Then we add 9 plus 2 is 11. 11 times 1 is 11. 5 plus 11 is 16. 16 times 1 is 16. Negative 15 plus 16 is 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. Negative 6 times 1 is negative 6. Now we notice that the sum here is equal to 0. So that tells us that 1 is a 0 of g of x. So now we're going to look for another 0. Now, since 1 worked, let's find out if 1 will work again. If it doesn't work, then we're going to try another number. Okay, so here we're testing if 2 is a double 0. So bring down the 2, or rather, if 1 is a double 0. Bring down the 2. 2 times 1 is 2. 11 plus 2 is 13. 13 times 1 is 13. 16 plus 13 is 29. 29 times 1 is 29. This becomes 30. And 30 times 1 gives us 30. And obviously, this is not a 0. So that means that 1 is not a double 0. So that means we have to try another number. Okay. So let's try 2. Oh, we should try negative 1 as well, but okay, we can try it later. So for now, let's try 2. So bring down 2. 2 times 2 is 4. 11 plus 4 is 15. 2 times 15 is 30. 16 plus 30 is 46. It looks like we're not going to get a 0. This is 92. 91 plus 92 is 93. Times 2 is a huge number, not 6. Therefore, we're not going to get a 0. So positive 2 doesn't work either. Okay, so let's try if negative 1 works. We haven't tried negative 1, right? So let's try. So we bring down 2. 2 times negative 1 is negative 2. 11 minus 2 is 9. 9 times negative 1 is negative 9. 16 minus 9 is 7. 7 times negative 1 is negative 7. 1 minus 7 is negative 6. And negative 6 times 6, negative 6 times negative 1 is positive 6. Now we're going to get here a 0. So we found our second 0. Now remember that since the degree is 5, we're looking for 5 zeros. So we found 2. That means we're still going to look for 3 zeros. All right. So let's try, well, negative 1 worked. Let's see if negative 1 will work again. Okay, so let's try that. So if not, then we find something else. So bring down the 2. 2 times negative 1 is negative 2. 9 minus 2 is 7. 7 times negative 1 is negative 7. This gives us a 0. 0 times negative 1 is 0. And that's not a 0. So that means negative 1 is not a double 0. So it seems like we're not going to get a double 0. So let's see. So we tried 1, we tried negative 1, we tried, and they are not double zeros at all. So we tried 2. So now let's try negative 2. So let's see if negative 2 works. So let's bring down 2. 2 times negative 2 is negative 4. 9 minus 4 is 5. 5 times negative 2 is negative 10. 7 minus 10 is negative 3. Negative 3 times negative 2 is positive 6. Negative 6 plus 6 gives us 0. Yay, we found another 0. Negative 2 is the third 0 that we found. Okay, so let's bring this up. Let's try another one. So what are we going to try? Now, these numbers that we are trying are the numbers that are in our list. We do not put anything here that's not in our list. Okay, so we tried 2 and negative 2 and it doesn't work. So now let's try 3. See if 3 works. Okay. So bring down 2. 2 times 3 is 6. 5 plus 6 is 11. 3 times 11 is 33, and it's not going to give us a 0. So positive 3 doesn't work. So then we're going to try negative 3. Does negative 3 work? So we bring down 2. 2 times negative 3 is negative 6. Negative 5 minus 6 is negative 1. Negative 1 times negative 3 is positive 3. And we found our fourth 0. So we have 1, 2, 3, 4 zeros already. Now we notice that the last numbers that we have here, we have only 3, 1, 2, 3 numbers, where the third is 0. That means that this is giving us the coefficients of a linear factor. So from here, we take the 2 and we make that the coefficient of x. So now we have 2x minus 1 equals 0. So now we can just solve for x here. So we'll add 1 to both sides. and therefore 2x is equal to 1. And then we divide both sides by 2. And so finally we'll have x is equal to 1/2. So now these are the 5 zeros of the function. 1, 2, 3, 4, 5. Okay, so maybe we can list that down. The zeros are these numbers. Now, notice that there are 2 negatives. All right, so there are 2 negatives and 3 are positive. So take a look. Let's validate our previous observation. Let's take a look at the sign changes. The first term here, this term is positive. This term is positive. This term is positive. This term is negative. This term is negative. And this term is positive. So how are the signs changing? So positive to positive, no change. Positive to positive, no change. Positive to negative, that is one change. Right? And then negative to negative, no change. Negative to positive, that's another change. So there's a total of 2 sign changes. Therefore, there should be 2 positive zeros. And that's exactly what we have. +1 and +1/2. The rest are negatives.